Hi, I'm Sarah, and in today's video we're going to explore how Van Heel's level of geometric thoughts can be used as a learning structure to teach Year 3 students about three-dimensional objects in line with the Kara content descriptor. Within this video, I'll provide you with language tools, teaching strategies and activities to use in the classroom to develop students' higher order of thinking in relation to 3D objects. These strategies and activities will be also beneficial to EALD students who may require additional visual support for learning new vocabulary. The first two levels of Van Heel's framework are pre-recognition and visualization. Students need to be able to recognize objects as three-dimensional shapes before they can classify and make deductions based on their object's properties. It will be beneficial to do a formative assessment at the beginning of the unit to test the students' recognition and visualization of familiar 3D objects. An activity like a shape hunt around the classroom would be appropriate activity to engage with. Our students need to be exposed to a variety of experiences regarding 3D objects to strengthen their understanding of shape properties. You need to engage the children in activities where they can not only recognize and visualize 3D objects, but also deconstruct and construct them using either their bodies or a variety of materials, as they will be eventually making models of these materials. Giving a student a physical object allows them to manipulate it to visualize the shape as a whole. They can see parts of the solid that would otherwise be hidden if it were printed on a piece of paper. This aids the student's spatial ability as they can develop their spatial orientation and spatial visualization by recalling on these objects. Through construction and deconstruction of these 3D objects, students can begin to sort, describe, and name them based on their visual features. Students begin to recognize and visualize the 3D objects. They may also start describing and grouping the solids based on non-defining attributes such as color, object use, and size, rather than defining properties of the object. As teachers, allow this deduction to occur, but then extend on it and show the students how the properties of a solid and the language we use defines what type of 3D object it is. Explicitly demonstrate to the students the language and the formal definitions of defining attributes of 3D objects to ensure the students have a conceptual understanding that coherently relates. For example, a cube is part of the polyhedron family based on its quadrilateral base and its faces all being equal. As you teach it, move around the object, count the faces, 1, 2, 3, 4, 5, 6. Make observations on its properties such as its 12 edges and 8 vertices. Decide if it is soft. Does it rock? Explicitly and physically exploring these defining attributes of a shape will progress the students up Van Heel's level of thought. This type of teaching will be especially important for EALD students who need this additional visual learning support. Reaching level 2 is vital for the students to be able to create their 3D models, as they need to be able to analyze and classify the objects that they model. Ensure you allow the students to gain control of their learning by working with you to analyze more 3D objects until you have progressively released the responsibility onto them. Gradual control of their learning will decrease the chances of misunderstanding and feeling of overwhelmment that can come with new learning. Activities such as "What 3D object am I?" can be utilized in the classroom for students to practice their deduction skills and engage in important discussion about the classification of solids. Through hands-on activities that apply the gradual release of responsibility framework, you'll be able to strengthen the students' geometric thoughts in line with Van Heel's levels of thought and ultimately teach them about 3D objects. They will have developed not only the language and understanding surrounding these 3D objects and solids, but also their properties and the resilience to face new challenges of transferring their knowledge. Lastly, ensure you create a real-world task for the students that aligns with the Kara descriptor. Activities such as construct a model of a new school building that contains 2 prisms, 3 cylinders, and at least 1 cone is an example of how students can combine their spatial abilities to visualize and recognize with their ability to analyze 3D solids based on defining attributes to then construct them to a 3D model of an object. Remember though that some students will need additional scaffolding and be offered alternative ways to understand and complete the task you require of them. Before I conclude this video, I have some questions regarding assessment that I'd like you to consider. How would you form an engaging summative assessment? Will data collection occur throughout the unit? How might you contextualize it so that the task relates to the student's real world? And how would you present the task to students who are EALD, and how might they present it to you? Thank you.